Now let's look at generating the conjugate of a complex number. Now if we have this complex number here, z is equal to 3 plus 4i, the complex conjugate is written as 3 minus 4i. So all we do is we take the imaginary part and we negate it. So if the imaginary part was positive, we make it negative. If it was negative, we make it positive. And we sometimes see the conjugate of a complex number written as z bar. Okay, so we put this little bar across the top of it. So this should be pretty straightforward within our assembly language code. We just need to pull out the imaginary part and negate it, and then save the complex number in a different memory location. So let's see this in our assembly language. On the right hand side we have the calling function, the left hand side the subroutine. So in the calling function we have the complex number 2 plus 3i, and then we have to have another complex number which we've called conjugate underscore address. So this is where we're going to save the conjugate, which in this case will be 2 minus 3i. And you can see we've got two memory locations set aside for this, one for the real part, one for the imaginary part. We push the complex number, we push the address for the that we want to save the result, and then we jump to the subroutine. So once we're in the subroutine, it goes ahead and generates the conjugate and saves the real part and the imaginary part into conjugate underscore address, and that's it finished. So on the left hand side, let's look at the actual calling function, so the actual subroutine. So we save the values of our registers into memory, we then pop the return address, we pop into register R3 the address of the result, and we pop into register R2 the address of the complex number. We then want to generate the real part, so the real part just remains the same, so there's no change. All we need to do is just load the value for the real part into register R0 and then store that value into the first part of the conjugate address, which is in register R3. We then move on to the imaginary part. So to get the imaginary part, we're going to have to increment the value in R3 and in R2. So this increments the address position for the result, and it increments the actual value that we're looking at, which is the imaginary value here, which is the value of 3. So we're going to load the new value, which is the value 3, into register R0. We then subtract that value from 0, this will negate it, and then we save the value in register R0. So this is the inversion from the plus 3i to minus 3i. We then store the result in R3, which is now pointing to the second part of this conjugate address, and that's us finished. So we can then load the values back into the registers. We jump to the return address, which is up here, and the next line is end, and that's the end of the code. So that's relatively straightforward. Let's see it working within our CPU. I have loaded everything into the CPU, so let's see it running. And again, it should run through pretty quickly, and if it works, it will take the number 2 plus 3i and it will return the number 2 minus 3i. So that's it finished now. Let's go in and we will have a look at the actual values within the RAM. So you can see here we have the original complex number, which is 2 plus 3i, and it returns the conjugate, which is 2 minus 3i. So FFFD is minus 3 in our 2's complement. So that works quite well. Let's move on and we will look at some other complex number functions within our CPU. Thank you for listening. I'll get you on the next video. Goodbye.